Station, Houston. Are you ready?
Houston Station, we're ready for the event.
Asa E Intermediate School, this is Mission Control Houston. Please call station for a voice check.
Station, this is Asa E Jr. at Asa E Jr. Intermediate School. How do you hear me? Station, this is Asa E Jr. at Asa E Jr. Intermediate School. How do you hear me?
Absolutely, we're standing by whenever things are worked out.
Station, this is Asa E Jr. at Asa E Jr. Intermediate School. How do you hear me?
We've got you loud and clear. Welcome aboard the International Space Station.
Commander Dan, this is Tyler Smeeby. What is your mission on the International Space Station, and what activities do you do to pass the time when not working?
Hi, Tyler. Actually, our missions are very many on board Space Station. Our primary mission right now is conducting science, and for the time that we'll spend aboard Space Station, which is about 6 months, we've got a little over 100 separate scientific investigations that we're working on. So that's the big piece of it. Another part of our mission is just keeping Space Station working and functioning. We have to be engineers, we have to be technicians, we have to be able to do all the ordinary things that you'd have to do to maintain your house if things break, for example. And we do all those things. In addition to that, we take care of ourselves, and occasionally we'll have visiting vehicles that'll bring up cargo. Occasionally we'll do robotic operations, and sometimes we'll catch those visiting vehicles. We expect to do that here in a couple of months. And sometimes we'll go outside and do spacewalks. But the primary mission is science.
Hi, Mr. Don. This is Dijon Taylor. How do you deal with minor and major injuries and/or illnesses while in space?
So far, we haven't had any major injuries in space, so we haven't had to deal with that. Minor injuries, like, if you could put a Band-Aid on it, you just put a Band-Aid on just like you do on the ground. We do practice, we do simulate what would happen if we were to have a major injury, and we've got medical equipment up here, sort of like what an emergency medical person would have, that we could do any number of medical procedures with help from doctors on the ground that we have in communication with. So we practice that every so often.
Commander Dan, this is Lauren Knight. How do you keep in contact with NASA and family members, and have you ever lost contact with Mission Control?
Okay, great question. It's really important for us to be able to talk to the people that help us fly the International Space Station. So we've got controllers that work at NASA in in the United States, but we've got controllers that also work all over the world in various control centers, including in Europe, including in Russia, Japan, and we've got other support centers all around, including in Canada as well. And we've got great communications channels with them. We can talk to them almost 95% of the time, pretty much any time we'd like. And we do that using satellites that are much higher than the International Space Station. And we basically ricochet our signal from space station to those satellites and then down to the ground and then to networks all around the world. We talk to our families sometimes as many times as a couple times a day, and we do it much like you would at home, almost like a cell phone, but we do that across a computer screen basically, and that's how we do that. But we've got really good communication capability on board.
Mr. Don, this is Diamond Spencer. How is the International Space Station protected from space debris? And can you feel when the debris hits the station?
Space station has what we call micrometeorite shielding on it. And this is shielding that will protect it from something maybe as big as a pea. But if it gets any bigger than that, we don't have any kind of shielding capable of protecting space station from larger objects like that. So small stuff, we're okay. The big stuff, we just are taking our chances with the universe.
Commander Dan, this is Melanie Castellanos. What is your most and least favorite part of being on the ISS?
Probably my most favorite thing about being on the International Space Station is just getting a chance to live and work in space and to do all the different things that we do and working with a lot of really smart, really talented people all over the world that help us make that possible. And every day is different. The variety of the things we do, whether it's science, whether it's maintaining space station, whether it's doing observations of planet Earth from here, or whether it's doing spacewalks, things like that, all the things we do, every single day is different. Every single day is exciting. That's my most favorite aspect of being here. Probably my least favorite aspect is the fact that you have to be away from your family for as long as you do. But thankfully, we get to talk to them. We get to actually see them on a computer screen at least once a week, in addition to talking to them whenever we can. So you feel like you're a lot more connected to your family than you otherwise would be, and you feel like you're a lot more connected to your family than many years ago than astronauts and cosmonauts used to be. So that part of it helps, but that's still the toughest part, I think, about being here.
Mr. Don, this is Alexis Facundo. Can you take personal items or electronics into space? And if yes, what did you bring?
You can take personal items into space. We're allowed a small bag, maybe about the size of a grocery shopping bag, of personal items that we can take into space. And some things are prohibited. We can't take electronic items into space. But all the items that we do take have to go through a safety review. For myself, I took a number of little things that I could use for science demonstrations. And for example, I brought some knitting needles with me. And it's not because I like to knit. I don't even know how to knit. But the knitting needles have some really neat characteristics. If you rub them with a piece of cloth, you can develop a small static charge, and you can do some static electric science demonstrations. So that's an example of something that I decided to bring in my personal kit.
Commander Dan, this is Andrew Davies. Did you always want to be an astronaut, and what kind of training did you have to do to be an astronaut?
Yeah, Andrew, I can't say honestly that I always wanted to be an astronaut, and that's because when I was young, when I was your age, it never occurred to me that this was something that I could do. And I was always interested in the space program and always read as much as I could about it ever since I was a kid, all the way up until my adult life. And it wasn't until I was a pilot and an engineer in the Coast Guard that I thought about applying to NASA to become an astronaut. And the things that you do the things that you learn, that you train on to become an astronaut are really cool. All of us come from very different backgrounds. We've got pilots, we've got engineers, we've got physicians, we even have veterinarians, we have teachers, we have people from all different kinds of backgrounds, but all of us have one common aspect, and that is we're all explorers at heart. Now, with that said, we still all have to learn all the basic skills that you need to have to be able to do the very different kind of strange sort of things you do on a space flight. So one of the first things we do when we go to NASA is we learn how to fly airplanes. We learn about meteorology, geology, oceanography. We learn about physics. We learn about astronomy. We learn about a whole host of different things that many of us might have been experts in before we came to NASA, but none of us know all those things. So it basically gives us a good background on all the kind of science that we do on board Space Station. And we learn how to be engineers. We learn how to be medical officers too. Don was talking about what would we do if we had a medical problem on station. We all learn a little bit about how to take care of each other. And we spent a lot of time in a great big pool practicing spacewalks at the Johnson Space Center, one of my favorite places. I think all of us love that. And it's the one place, the unique place that we can go and experience what it's like to be weightless in space. And we wear spacesuits just like we'd wear outside the space station underwater. And we practice building space station there.
Mr. Don, this is William Jones. How many times can an astronaut go into space, and how long can they stay there?
Well, currently, our missions are planned for about 6 months. And maybe it'll be a month longer, maybe it'll be a month shorter. But 6 months is the normal mission duration for space station at this point in time. How many times can you do this? Well, from a radiation point of view, you get about 10% of your allowed radiation limit for each space station mission. So this is my second mission, so in concept I could do this 8 more times. However, if you fly once every 6 to 10 years, you're going to be close to 100 years old by the time you get done flying your 10 missions. So the number of missions a person flies typically depends on how long you have a career as an astronaut.
Commander Dan, this is Sarah Hale. What challenges do you face when completing day-to-day activities like haircuts, for instance?
Yeah, that's another thing you have to do. So in addition to being scientist, engineer, and spacewalker, and all these other things, you got to be able to cut hair. And I think all of us in theory might have practiced that before we came here, but none of us ever did it until we actually got here and we were faced with one of our crewmates who needed a haircut. And so we basically will start cutting each other's hair, and if we make a mistake, the hair will get a little shorter and a little shorter, and eventually it'll be relatively even. A lot of the things that we do are just basic kinds of things that everybody has to do living on planet Earth. And cleaning space station, for example, is a very challenging thing. If you have to clean your room, the things that are laying about literally are laying on the floor, so they're all generally in one place. It may look like a mess, but it's a lot easier to clean that than it is to clean a place where all of those things could end up on the floor, the walls, the ceiling, in any corner you could imagine. So we get very creative and about how we take care of all the routine things as well.
Mr. Don, this is Cody Tecklenburg. Do you have a procedure in place in case you find other forms of life in space?
Nobody is really anticipating finding other forms of life, like extraterrestrial forms of life in space at this point in time. We're still debating whether or not we've found any such fossil forms in meteorites that we have confirmed that come from Mars. Now, whether there are other forms of microbial life, that's something that maybe your generation will discover. But what we do have in place now are how we deal with microbial forms of life that come from planet Earth. We have or have done experiments that involve bacteria and virus, and we have to make sure that they are double or triple contained so that they won't spill out of their Petri dishes. And then there are other unwanted forms of life that we have to keep in control. For example, mold and mildew, just like it could grow in your bathroom walls, it could grow up here. And so we have to clean and disinfect areas of space station to keep unwanted things like that from happening. And then when we have our food wrappers and things, pouches that our food was rehydrated in, and then you eat the food, but there's always a little bit of residue. That could turn into a biological experiment itself. And so we have ways to deal with our wet food wrapper waste. So most of the things we have on space station right now in terms of microbial life forms are how do we deal with these that come from planet Earth?
Commander Dan, this is Caleb Hernandez. How hard is it to maintain a good relationship with each other in such a small space for long periods of time?
That's an interesting question. I think in my experience, and maybe it's the thing that I said earlier, the fact that all of us, even though we come from different backgrounds, all at heart love what we're doing, all at heart believe in the necessity for human beings to explore. And so all of us are very happy. All of us really get along well, incredibly well. And we were all great friends long before we climbed aboard rockets and headed up to the International Space Station. And I think in general that's pretty much been the experience throughout the space program. But it is a challenge. I think if you look at doing deep space missions where you were to go perhaps to Mars, for example, for a couple of years and be in very close quarters, it's really, really important for people that do those kinds of missions to be very empathetic, sympathetic, to be able to really genuinely care about the folks around them and be willing to give each other the amount of space that you need. But this is a teamwork. Flying in space is a team sport. And it can be a dangerous team sport, and I think it's important to really, really care about those that you fly with.
Mr. Don, this is Medina Bearcat. Do you celebrate holidays in space, and if yes, how?
Do we celebrate holidays in space? Of course we celebrate holidays in space. Anytime you're away from home for long periods of time, particularly in a frontier, human beings celebrate holidays. We did this when America was being settled. We do it as scientists in Antarctica. We also do it in space. And since it's an international space station, we get to celebrate not only the American holidays, but we get to celebrate key international holidays as well.
Commander Dan, this is Lauren Young. Can you use cell phones in space?
Well, I guess you really can't use cell phones. Cell phones rely on radio towers that are on planet Earth, and at any given time from the space station, we can see an area of planet Earth that covers thousands and thousands of miles from horizon to horizon. You could probably see 1,000, maybe 10,000 cell towers in that area. So for a lot of technical reasons, we don't use cell phones. The communication systems we have on board station are specifically designed for station and use satellites and relay links that connect to ground stations. And the communications for us would be almost like, it would feel a little bit like using cell phones. You can call friends and family when you have the time, and you can do that through your laptop computer, and it's very similar to using cell phones, but we can't use real cell phones.
Mr. Don, this is Jaquelius Coleman. Why is going to space necessary, and what has been the biggest discovery?
We're doing a number of different science experiments right now. Some are biological experiments on ourselves where we're guinea pigs, and then we do a number of physical science experiments, combustion, crystallization, things like that. And to see a major breakthrough takes quite a few years. And it's something that's slow in coming, and it's something that lots of people on the ground have to sit and think about what the results are before everyone decides that, wow, this is really significant. So for these kinds of results, we will have to wait and see what comes from space station.
Commander Dan, Station. This is Emma Chan. How will equipment and supplies be lifted to the ISS now that the shuttle program has been discontinued?
Now, great question. We have cargo ships that come up from Russia. In fact, we just 4 days ago received one on board Space Station, and that's been a steady means for us to get cargo for a long time since the space station started, in addition to the space shuttles. The space shuttle up mass capability, that is the ability to lift cargo from Earth to bring it to station, is being replaced by commercial vehicles, and the very first of those is going to come in a couple of months to space station. So we've got a number of those that'll come. The Europeans have an automated transfer vehicle, which is a large cargo vehicle that also has been to space station and will also in a couple of months be coming back. And the Japanese have one as well, the HTV, or Hope Transfer Vehicle. So we've got lots of ways to get cargo to station. We don't have very many ways to get cargo from space station. Right now, if we want to bring something back to planet Earth, we're limited to the relatively small volume we have in the capsule, the spacecraft that we're going to ourselves ride back to planet Earth when it's time to return. And we very much need, I think we very much would like to have a capability of soft landing large amounts of cargo. And the cargo could be equipment that we want to repair, but it could also be a lot of the science samples that we have on board Space Station. And the vehicle that's going to come up here in a couple of months from Space Exploration Technologies, that vehicle should have the capability of returning cargo from Space Station, something that the shuttle up till now has been exclusively capable of doing.
Hi, Mr. Don. This is Patrick Wickstrom. Do you sweat in space? If yes, does it float?
Do we sweat in space? Of course we sweat in space. When we do our exercise, particularly our cardiovascular exercise, you get covered in sweat, and on your head, the sweat doesn't run down like it does in Earth. It just kind of beads up in little sweat balls stuck in your forehead and on your hair. And then if you move your head quickly like that, all these little sweat balls just fly off of your head and go scattering everywhere around where you happen to be. And so you learn after a while, when you're all covered with these sweat balls, not to shake your head quickly, and you get a towel or something and you dry yourself off a little bit before you do a sudden move.
Thank you, International Space Station. Thank you so much. It's our honor.
And Asa E Schools, thanks very much for being with us today. It was great to talk with you. There were great questions the kids had, and we look forward very much to them pursuing careers in science and technology, engineering and math, if that's what they'd like to do down the road. We very much need their energy and their ideas in the space program of the future. Thank you.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you, Asa E Intermediate School. Station, we are now resuming operational comms.